Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to learn about the ratio test. Another test on our series test adventure. So let's get started and see how this one works. All right, ratio test. So let the sum from n equals 1 to infinity of a sub n be a given series. Then by the ratio test, if the limit of a sub n plus 1 over a sub n is less than 1, then the series converges. And it converges absolutely. Okay, you're taking the absolute value of this series. It converges absolutely. All right, if the limit as n goes to infinity of a sub n plus 1 over a sub n is greater than 1 or infinity, the series diverges. And if the limit is equal to 1, the ratio test fails, doesn't work. You got to use another test. Okay. The ratio test is really good for factorials. All right. And a sub n if it's not a geometric series. Okay, so if you have something that's not, that should be a sub or a to the power. Oh yeah, a to the power n. Right. So like 4 to the n if it's not geometric. Okay, and you'll see that coming up in just a moment. All right. But first, before we do that, let's take a look at case 3. So let's show that in case 3, the test fails. We're going to use the ratio test on these two series. So this first series, this is the harmonic series, right? This diverges. I know that. And this series is a p series with p greater than 1. So this series converges. I know that. But let's try the ratio test. So the ratio test says I'm going to take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. So basically all that means is to find a sub n plus 1, I'm just going to replace all the n's in this series with n plus 1's. So that's going to be the absolute value of 1 over, replace n with n plus 1, over a sub n. That's the original series, 1 over n. I forgot the limit sign. Okay, so now I'm going to flip that bottom fraction over. I get 1 over n plus 1 times n over 1. So now I can divide by the dominant power, divide all these out, or use L'Hopital's rule, and I get 1. Okay, so we claim 1 makes the test fail. All right, so let's try this one over here. 1 over n squared. Same idea. We're going to try the ratio test. Take the limit as n goes to infinity. 1 over, so a sub n plus 1 means replace all the n's with n plus 1's. So I replace the n with n plus 1, and then it's squared, over 1 over n squared. So that's the limit as n approaches infinity of n squared over n plus 1 squared in absolute value. So now I'm going to divide by the dominant power again. The dominant power now is n squared, right? There's n squared on the top and an n squared on the bottom. If I FOIL this, multiply it out, right? So that would give me, well, if I multiply it out just so that we can see it, it's n squared over n squared plus 2n plus 1. And then I'm going to divide everybody by the dominant power, divide everybody by n squared, or use L'Hopital's rule. So n squared over n squared over n squared, plus 2n over n squared, plus 1 over n squared. That's going to be 1 over 1 plus 2 over n goes to infinity, 0. That's a 0. I get 1. The result is 1. So the ratio test for both of these series gives 1 as its answer. But I know that this first series diverges, and I know that series converges. So in this case, the ratio test does in fact fail. All right. All right. Now let's put the ratio test to the test. Let's determine if the series converges or diverges. So here's a series that you actually know nothing about. 4 to the n over n factorial. All right. The question is, how do I know if this series converges or diverges? Well, I can't really compare it to anything because I don't know anything, if that converges or diverges that to compare it to. It's not geometric because of the n factorial in the denominator. Okay. The nth term test for divergence doesn't tell me anything. So I'm going to try the ratio test. So to use the ratio test, I'm going to find a sub n plus 1. So that's 4. Replace all the n's with n plus 1s. Over, replace n with n plus 1. And then divide that by the original series, 4 to the n over n. Excited n. Okay. So now let's take the limit as n goes to infinity. Flip this stuff up. 4 to the n plus 1 over n plus 1 factorial times n factorial over 4 to the n. All right. So now we got to try to clean this up a little bit to take the limit as n goes to infinity. So what we're going to do is we're going to do a little bit of algebra here. So 4 to the n plus 1 is really 4 to the n times 4 to the first, right? Because I add their exponents, times n factorial. N plus 1 factorial. So let's write it up here what it means so that you kind of get used to working with factorials, which you're going to have to be able to do. N plus 1 factorial means you're going to multiply 1 times 2 times 3 times 4 times however many you're going to multiply times n times the last term is n plus 1, right? So n plus 1 factorial, that's what n plus 1 factorial is equal to. So n plus 1 factorial is really n factorial times n plus 1. So now take a second to digest that. Take a look, okay? Because if I look at what n factorial is equal to, it means multiply all the numbers up until you reach n, and then do n plus 1 as well. So if I take all of these together on their own, well, this is really just n factorial times the next term also, n plus 1. Now that helps me tremendously, right? Oh, and I have 4 to the n in the denominator as well. That helps me tremendously because now this n factorial and that n factorial cancel out. This 4 to the n and that 4 to the n cancel out. And now I get the limit as n approaches infinity of 4 over n plus 1. The limit as n goes to infinity of 4 over n plus 1 is 0. 4 over something really big is really small. That's 0. That answer is less than 1. So then this series converges absolutely by the ratio test. The ratio test is extremely important. You're going to see it in the second half of this chapter as well. It's all over it. Okay? So it's really a test that you need to be aware of and understand how to work, and also how to understand and manipulate, play with the algebra here to get a final limit or a final answer. All right, let's try another one. It's the sum from n equals 0 to infinity, n squared times 4 to the n over 3 to the n plus 1. Okay, so I'm going to try the ratio test on this again. Again, I can't use like the geometric series test because of this n squared that's sitting here. I might be able to compare it to something. I'm not sure, but this is the ratio test video, so we're going to do that. All right, so we got a sub n plus 1. I'm going to change all the n's to n plus 1s. 4 to the n plus 1, 3 to the n plus 1, plus 1, right? So n gets changed to n plus 1, and there's still a plus 1 there. Times, or divided by, let's divide it by again. So n squared times 4 to the n over 3 to the n plus 1. All right, now we're going to rewrite this thing. So that's n plus 1 squared times 4 to the n plus 1 over 3 to the n plus 2 times 3 to the n plus 1 over n squared times 4 to the n. Let's take off some of this absolute value bar there. Now we got to try to algebraically clean this thing up. So let's take a look. We're going to try to gather some things together here. Well, we were in this same scenario a minute ago. 4 to the n plus 1 over 4 to the n. So let's take the 4 to the n plus 1, rewrite it as 4 to the n times 4 to the 1. This n plus 1 squared, I'm just going to leave it there. 3 to the n plus 1 over 3 to the n plus 2. So the denominator is like 3 to the n times 3 squared. This is 3 to the n times 3 to the 1. And then there's also an n squared in the denominator and 4 to the n in the denominator. It's easy to get lost here with all the stuff that you have that you're writing down. The better you get at simplifying this, the faster you're able to do it, the better off you'll be, I think, rather than writing all these extra steps here. So 4 to the n's, they drop out. 3 to the n's drop out. That's 4 to the first there. So I have, I forgot the limit sign. So we have the limit and goes to infinity of 4 times, well, this is 3 squared, 3 over 3 squared. These need 1 power 3 in the denominator. And then I still have the n plus 1 squared over n squared. But as n goes to infinity, that means I'm going to have n squared on the top. There's n squared on the bottom. So this limit, if I calculate this limit, it would be 1. So that's 4/3 times 1. The 4/3 doesn't matter in the limit. It doesn't have an n. It's going to be 4/3. That's greater than 1, right? 1 1/3. So this series diverges by the ratio test. Okay? And again, there's other ways to make this a little bit easier to simplify, like 4 to the n plus 1 over 4 to the n. So 4 to the n plus 1 has 1 more power of 4 than 4 to the n, so all that'll be left will be 1 power of 4. This one has 1 more power of 3 than that one does. This one has n plus 2, that one has n plus 1, so there'll be 1 power of 3 remaining in the denominator. So that's what I mean by trying to do this faster, only because it saves you a lot of time and headache here writing all this stuff out. Okay, last one. Let's try n over 2n plus 1 factorial. All right. So we're going to take the limit then. We're going to use the ratio test again. And we're going to have n plus 1 over, replace all the n's with n plus 1. So it's 2 times the quantity n plus 1 under the factorial. Times, let's flip this thing over, 2n plus 1 factorial over n. Okay, so now let's clean up the new denominator there, I guess. There is a little bit to do. So we have n plus 1 times 2n plus 1 factorial over, that's 2n plus 3 factorial times n. All right, so now we have n plus 1 over n. So I'm going to put those two together. Let me put them here at the back. And then I have the 2n plus 1 factorial over 2n plus 3 factorial. Okay, so this term has, let's see, 2n plus 3. So for example, if I were to start writing it out, I would have, starting from 0, I'd have 3 factorial, or we'd have 3. Oh no, we're going to start from 1. So if I plug in 1, that would give me 5 factorial. And then 2 would give me 7 factorial, 9 factorial. This is all odds. This is also all odds, right? So this would have 3 factorial, 5 factorial, 7 factorial. So this one has 1 more than this one does. So this one's going to have a 2n plus 3 in the denominator. So now that gives me n plus 1. I need the limit sign. over 2n squared plus 3n. The dominant power is n squared. If I divide by n squared, the larger power's on the bottom, so the limit as n goes to infinity will be 0. This is less than 1. So again, this converges absolutely by the ratio test. And that's it. That's how the ratio test works. As always, thanks for clicking.